So, what we have here is two cars A and B travel along two straight roads which intersects at an angle tan theta equals 4 over 3. I'm quickly just going to write down what sine theta and cos theta are in the corner. The opposite is 4, so sine theta is 4 over 5, and for cos theta it's 3 over 5. Okay, A is moving towards a 5, B is moving towards that 10. Okay, at a certain instance, each car is 100 meters from the intersection and approaching the intersection. Find the velocity of A relative to B, and then the shortest distance between the cars. What I reckon we do first and foremost is we get points on the board, and we sort out phi A, B. Write down phi A, B, write down phi A minus phi B, and get yourself some points on the board. So here's what we're going to do. We're going to do phi A starting off, which is really easy. What's phi A, guys? Phi A? 5i. Not too stressful. Phi B? A little bit more stressful. I'm going to use alternate angles. Everybody see that? So I'm just going to draw a B like this, and I'm going to specify that's sort of an alternate angle there. And then I'm going to draw a quick triangle, like so. And then we get theta. And what's this one again? It's 10, isn't it? So that makes that 10 cos theta, and makes that one 10 sine theta. 10 sine theta is 8, 10 cos theta is 6. 6 and 8. So what I can get here is this. Phi B equals 6i plus 8j. Velocity of A relative to B is what, guys? It's going to be 5i minus bracket 6i plus 8j. And finally that's going to be minus 1i minus 8j. And that's it at the moment, right? What I always tend to do myself is I always tend to just quickly draw another triangle of the velocity of A relative to B. What direction is it going in? Huh? South, west, yeah? Now that's interesting. Southwest. Let me see. Southwest. Okay, so we are traveling 8 down and 1 across. Is that right? 8 down, 1 across. So that's a really steep one. So something like that down this way. Alright, and what I'm going to do, that's pinned into the axis. So that's 1 across, 8 down. What's the inverse of that? Tan inverse 8. You can just quickly do it here. Tan inverse 8. 87.875. Sorry, 82.875, yeah? So this angle, 82.875 degrees, okay? And what is the Pythagoras theorem on that? I'll go for root 65. Okay. So, at the moment, A and B were 100 away from each other. Like so. And which way is B travelling? Sorry? They're both travelling towards the intersection, which is great. Who's going to make the intersection first? B. Okay, so B's going to make that intersection first. And how many seconds will B make it to the intersection? 10 seconds into the future, right? So here's what we're going to do. T equals 10 seconds in the future. We now have a new scenario. The scenario we have is the crossroads is here. B is at the junction after going through its diagonal road. A is still on the lateral road on its way towards B. How far is A away from the junction after this time? A has travelled 50 meters in this time frame of 10 seconds. It's now currently 50 meters away. 50 meters away. We stop time right here. What is the velocity of A relative to B. And we're about to encounter a problem, aren't we? Why are we about to encounter a problem? Sorry? It's going away from it. -1 across, 8 down. Is that correct? Velocity of A relative to B. I'm just rereading the question here. It's going away from it. What does that mean? What we have is this, guys, right? A really easy trick. Remember I was talking to you about whether you need to go back in time or you need to stay where you are. We now know, because A is currently travelling away from B once B reaches the junction, this means that basically the closest distance has already occurred. And what it has done is it occurred before 10 seconds in. So what I'm going to do is I'm going to extend the line back using a different colour here, okay? So I'm just going to do it from about here. And I'm extending this line back. Where is the closest distance then? This pink line here. Is everybody happy with that? Now, here's the trick. And it's a really quick trick, okay? No need to rewrite it. All you have to do is this. 50 meters from A to B. Everybody happy enough with that? Alpha was here. This alpha actually represents what angle? It represents our 82 degrees and 82.875. Is everybody happy with that? Because it's the relative path. Use opposite angles to now form that being alpha. You're now looking, that's a right angle triangle. What side is the pink side? The opposite. You're looking for the opposite side. The opposite side, therefore, is sine alpha equals our closest distance over 50 equals 50 sine 82.875, and then 50 sine 82.875, and what do we get? 49 meters, yeah? 49.61. Okay, so 49.61. Okay, it's 50 sine 82.875, which is 49.6 kilometers. I'm going to do you a bonus here, okay? I'm going to ask you, after how many seconds did this actually happen? When did it happen? That's a really good question, right? Is when did it happen? When did the shortest distance actually happen? When B reaches the junction, how far in the future was that? 10 seconds. It's 10 seconds gone. We've all agreed that the closest approach happened before 10 seconds. Everybody agreed with that? So therefore, I need to find how this distance here. First of all, how long is this distance? Can anybody tell me how to find the green distance? Pythagoras would work well, or I could also use 50 cos 82.875. And what do I get there? Chest is tight. Cos 6.202, okay? Now, please remember, this is not actually, B didn't cover 6.2, A didn't cover 6.2, A covered that relative to B, which means that I'm only talking about their speeds. How fast was A going relative to B again? Route 65 is how fast it was going. So it covered an extra 6.2 kilometers in this extra time. What's 6.2 divided by route 65? I'm basically doing distance. I'm doing relative distance over relative speed. Sorry? 0.77. That's how long it took for that to happen. So, long story short, guys, 0.77, yeah? What we can do here is this. If that's 0.77, that means that this closest approach occurred when? 0.77 seconds before 10, which is 9.23. Okay? 9.23 seconds in. I can do Oh dear. A woman can row about at 4 meters per second in still water. She rows across a river 80 meters wide. The river flows at a constant speed of 3.5. She's able to go directly across. How do I know that? She can travel faster than the water. She wishes to land between B and C. The point B is directly across. However, the point C is 20 root 3 downstream. 20 root 3 right there. If theta is the direction she takes, find the range of values of theta she can land between B and C. It's very easy. It's broken up into two parts. Ignore C even exists for the time being. Completely blank it out. All we're going to do is focus in on this region here. Is everybody alright with that? Here's what you're going to do. To go directly across, what must you do with your angle theta? When you aim your speed across, what must you do? Your two components have to do what? Your I component has to counteract the 3.5 meters per second by the stream. That means you're going 3.5 to the left to counter the stream's 3.5 to the right. Does that make sense? The next thing you gotta do is, you know that you can go, your hypotenuse is 4. You can travel 4 in still water. What does that leave for your opposite? What can we do there? Sorry? We can do 4 squared minus 3.5 squared. Root the answer. Answer. Root 15 over 2, otherwise known as 1.396. 1.3965, I think would be better. Now, the next thing, if you zone in on the language of the question, do we need to figure out how long it takes us to get across? Does it ask us anything about time? No. If we are asked for time, it'd simply be our 80 meters going upwards divided by, say we're there, 1.9365. It would actually take us 41 seconds to get across. Alright, that's a no-brainer. Alright, but what we're interested in is the angle. How do I get that angle? The two green lines are the ones I got originally. So how do I work that? Cos theta equals 3.5 over 4. Theta therefore equals what, guys? Cos inverse 3.5 divided by 4, and what we get is 28.96. Okay, so 28.96. I've figured out what angle she needs to take to go directly across. What angle do you think she'll need to take just to drift a bit downstream? It'll be a slightly bigger angle. You're reducing the 3.5. You're sacrificing the 3.5 to make the 1.93 a bit bigger because you're aiming more upwards. Your opposite side relative to your adjacent side is getting bigger. Okay? So here's what we have to do this time. What we do is we figure out this angle here. We figure out what did we actually do? How did we actually go from A to C is what we want to figure out. So here's what's going to happen. You just draw your relative velocity down. Velocity of the woman, they use woman again. Girl. Velocity of girl in water. Everybody alright with that? Is the velocity of the girl minus the velocity of the water. The actual velocity of the girl is the velocity of the girl in water plus the velocity of the water. I.e., if you can swim at 5 meters per second and the water is going 3 meters per second, you're going 8 meters per second. That's why they're getting added together. Now look at this. What actually happens to the impartial observer looking at it at the side is this. She observes that the person actually travels 80 meters across, but they also travel, what else happens? They also travel 20 root 3 across. What I can do from this is I can determine its angle. What angle is this then? tan inverse 80 over 20 root 3. Are you happy with that? 80 divided by tan 20 root 3. So look at this. So, oh dear. Somebody tan inverse that for me, check it out. So what you say? 66.6 basically, is it? Okay, thanks. Sorry about that. 66.6, okay? Now, this angle A, we'll call it angle A, is 66.6. If we look at the start of the question and we zone in on it, we move across with an angle theta. Does everybody agree with that? The water then pushes us to the right. And then we actually go this direction here. This is how we aim. This is the velocity of the Garland water. We aim this direction. The velocity of the water pushes us in this direction. Alright? And the way we actually go is the velocity of the girl, which is in this direction. What angle is this angle in here? 66.6, which is an alternate angle to 66.6 there. Where's the theta going to go, guys? The theta is an alternate angle to that one up there. What's the velocity of the water? 3.5. What's the velocity of the Garland water? What's the velocity of the Garland water, guys? The Garland water is 4. Do we have enough information to answer this question? We have angle, and we can call this angle x, can't we? So sine x over 3.5 equals sine 66.6 all over 4. Somebody get on the calculator really quickly. Will somebody sine inverse 3.5 sine 66.6 all over 4? If you inverse that, we pretty much have our answer. So what is it? You can 42. X is equal to 53.42. Then also what we got to do is get 180, because that's 53.42. Our theta angle is going to be 180 minus 66.6 minus 34. Sorry, what's it? 30. He's told me 34.82. And what we get here is this 180 minus 66.6 minus 34.82. Sorry. And the answer is 78.58. Okay, done.